In a recent study, scientists have used observations of a fierce class of black holes known as quasars to demonstrate time dilation in the early universe. This study reveals that time in the early universe passed only about a fifth as quickly as it does today. These observations stretch back to about 12.3 billion years ago, when the universe was roughly a tenth of its present age. Quasars, some of the brightest objects in the universe, were used as a clock in the study to measure time in the deep past. Quasars are incredibly active supermassive black holes, millions to billions of times more massive than our Sun, usually found at the centers of galaxies. They consume matter drawn to them by their immense gravitational pull and release torrents of radiation, including jets of high-energy particles, while a glowing disk of matter spins around them. The researchers used observations involving the brightness of 190 quasars across the universe dating back to about 1.5 billion years after the Big Bang. They compared the brightness of these quasars at various wavelengths to that of quasars existing today. The findings showed that certain fluctuations that occur in a specific amount of time today did so 5 times more slowly in the most ancient quasars. Astrophysicist Geraint Lewis of the University of Sydney in Australia, the lead author of the study, explained that this continual expansion of the universe is the reason why time flowed more slowly earlier in the universe's history relative to today. However, it's not as if everything was in slow motion back then. If you could be transported back to that time, a second would still feel like a second to you. But from the perspective of a person today, a second back then would unfold in 5 seconds now. This study adds to our understanding of time and its complexities, and opens up exciting possibilities for the future, including time travel and warp drives.